In this session, we'll explore the Boardwalk Single Schema data model to understand where user and table names are stored. We'll then explore how, given a table name, we can access the columns and rows of the table within the database. Once we have identified the columns and rows, we'll discuss how to narrow down to the cell level. Subsequently, we'll investigate how cell values are stored and how changes are recorded within the database. This comprehensive exploration will provide insights into the data management system and its mechanisms within Boardwalk. Now that we have our simple application up and running, let us spend some time understanding how the data is stored within the Boardwalk platform. We will now explore the different components of the single schema. I have connected to the database server and am going to query the database associated with our application. We will start by querying the database for the users that have access to the database. The query is straightforward. Select star from VW_user. On execution of the query, the results are displayed. The first column is the ID column. Currently, there are only 5 users in the database. Single-digit IDs are system-generated default IDs. The 4-digit IDs are the ones that are created for all the other users. The user's login is the email address. Every user has an external ID, which currently is the same as their login ID, except in the case of the system-generated login, it is set to -1. The password is encrypted. The next 2 columns are the first name and the last name of the user. The active column indicates whether the user is active or not. A 1 indicating that they are active and a 0 indicating they are inactive. The is_admin column indicates whether the user has administrative privileges or not. A 1 indicates that they have administrative privileges and a 0 indicates no administrative privileges. The column created on shows you the date on which the user was created. If the password was changed, it would reflect in the password changed on column. By default, the value would be the same as created on. The next column indicates when the user logged in last. Sometimes a user can get locked out, which can happen if their login attempts were unsuccessful a number of times. The threshold of unsuccessful passwords can be set by the system administrator. The number of unsuccessful logins tries are also tracked. So, there is a lot of information stored in this table that can help system administrators. Now let's explore where the tables are stored. All Boardwalk tables are stored in the VW_TBL table. By running the query, select star from VW_TBL, the list of tables in our database will be displayed, including tables to manage integrations. The system-generated tables start with an ID of 1 million, and the user-generated tables start with 2 million. So, let's refine our query to only show user-generated tables. Upon scrolling to the bottom of the output, we observed a total of 47 user tables within this database. Notice, the tables we previously created, namely region, transactions, and LOV, are among them. We will now focus on the transactions table and understand how the data is stored in Boardwalk for this table. Let us take note of the ID for this table, which is 2,040,000. Let's examine our transaction table, which mirrors the Excel workbook. In this instance, we have 16 columns, comprising 15 data columns and a final column labeled BWID. While there are 80 rows in total, including the header, only 29 are currently visible on the screen. By scrolling down on our workbook, we can uncover the remaining rows. Our next step involves investigating how this data is stored within the database. We will now run a query on the database to see the columns that belong to the transaction table. Select star from VW_column where BW_TBL_ID equals 2,040,000 gives us the list of columns for the transaction table. Let us now examine the result of this query. The result contains 16 rows, corresponding to the number of columns in our worksheet. The first column serves as the ID column, unique for each column in the spreadsheet and within the database. Following that, we have the name column, representing the name of each column in our worksheet. The BW_TBL_ID column lists the ID of the table associated with these columns, in our case, the transaction table. All data within Boardwalk is stored as strings, hence the column underscore type for each column is designated as string. The sequence_number column denotes the order in which columns appear on the worksheet, preserving the positional arrangement of data elements. The TX_ID column indicates the transaction ID responsible for creating these columns. Another crucial column is active, with a value of 1 denoting an active column and 0 indicating an inactive one. In Boardwalk, column deletion involves marking columns as inactive rather than removing them outright. Consequently, when examining the table history, any deleted columns will be indicated accordingly. Now, we'll execute a database query to retrieve the rows belonging to our transactions table. Running the query, select star from bw_row where bw_tbl_id equals 2,040 provides us with the list of rows for our transactions table. Let's proceed to examine the outcome of this query. The result contains 79 rows, corresponding to the number of data rows in the worksheet. The first column, ID, is unique for every row in the worksheet, as well as any data row in the database. The ID of the row can also be found in the worksheet under the column BWD. You will notice that the name column is blank, as the row does not have a name associated with it. BW_TBL_ID is the ID of the table to which a row belongs. The TX_ID column indicates the transaction ID responsible for creating these rows. The sequence_number column denotes the order in which columns appear on the worksheet, preserving the positional arrangement of data elements. Another crucial column is active, with a value of 1 denoting an active column and 0 indicating an inactive one. Owner_ID column indicates the ID of the user who created the row. As in the case of columns, rows are not physically deleted, but marked as inactive, and hence, when reviewing the table history, any deleted rows will be indicated accordingly. The intersection of a row and a column yields a cell. We will now explore how data stored in a cell within the worksheet is managed within the Boardwalk ledger. Each cell stored in this database possesses a unique ID, stored in the ID column. The BW_row_ID column indicates the row to which the cell belongs, while the BW_column_ID column indicates the associated column. Boardwalk uniformly stores all values as strings within the database, hence the cell type is string. Every change a cell undergoes is meticulously recorded in Boardwalk. The string value table retains a historical record of all values the cell has held. The latest values ID is stored in the BW_string_value_ID column, while the actual latest value resides in the string_value column. If there is a formula in the cell, then that formula would be stored in the formula column and would have displayed in the output. The TX_ID column holds the database transaction ID responsible for the latest update to the cell. As with other Boardwalk tables, an active column tracks the cell's status, with a value of 1 indicating active and 0 indicating inactive. In Boardwalk, cells are never deleted. Instead, they are marked as inactive. Consequently, deleted cells will be reflected accordingly in the table history. Since our query gave us the data on all the cells in the database, we will now learn how to navigate this data to find the information we are looking for. For our example, we will consider the cell F2. To find the cell in the database, we need to know the coordinates of the cell, which are column ID and row ID. We know the row ID of the cell from the BWID column, which is 1205. The name of the column of the cell is TXNamount. We can find the column ID from our earlier query on the columns of our sample table, which is 1533. Armed with this information, we can further enhance our query to get to the cell. The value that is returned is 74787 for the cell in F2. You may have noticed that this value is different from the value that is shown in the worksheet, which is 74,787.88. Let us dig deeper to figure out what is happening. Let us note the ID of the cell, which is 4148. We will query the BW_string_value table to find out more details for the cell. The query results display 3 rows for the cell, each corresponding to a different TX ID. Initially, TX ID 1333 represents the creation of the original cell value, recorded as 74,787.88. Subsequently, TX ID 1474 captures an update to the value, changing it to 74,700.88. The final update, recorded under TXID 1475, revises the value to 74787. In summary, the cell underwent 2 value changes, all meticulously stored within the database. When we run cell history for the cell in the worksheet, we will see the same results. Executing the cell history command for the cell in the worksheet yields identical results. We observe 2 value changes and gain additional insights. The cell's creation was executed by the admin user, with the creation date duly recorded. Additionally, in the comment column, the user's intention, link export new table, is documented. Subsequent alterations to the cell were made by the user Ronald, with the modification date and user's intention also noted in the comment column. Nevertheless, there exists a discrepancy of 0.88 cents between the value in the spreadsheet and the database. This discrepancy suggests that the value was updated in the workbook but was not subsequently submitted to the database. Such oversights are common, where changes are made locally but not reflected in the database. If changes are not submitted, they remain local and inaccessible to other users. Upon submitting the change in the worksheet and reviewing the cell history, we confirm that the change has now been accurately recorded in the database. Executing our previous query for the cell in the database, we observe a new row recorded, indicating the latest value with a transaction ID of 1538. The value of the cell now is 74,787.88, and this corresponds to the value in the spreadsheet for that cell. Additionally, when we run the query on the BW cell table, we find the same value there too, with the TX ID updated. Now, let's explore the BW_TXS table, which stores all transactions on Boardwalk tables. We'll narrow down our query to retrieve records specifically for the transactions involving cell F2 in our spreadsheet, leveraging the known transaction IDs. Notice that the output is very similar to one that is produced by the cell history function of the Boardwalk template, the user who made the change, denoted by created by column, date and time of the change as denoted by created on, description of the change, and the intent of the change denoted by the comment column. Boardwalk Single Schema gives you the leverage to move your Excel-based application quickly to a database-supported Excel application, eliminating the complexity of modeling your application to fit a database.